Hi everyone. In this video, we're going to be talking about the zeros of polynomials. Okay, now remember, we've already learned that the zeros are also the x-intercepts, the solutions to the equation, and sometimes we also call them the roots. Okay, now, the zeros of polynomials, so for instance, if c is a real number and p is a polynomial, then the following statements are equivalent. So we could say that c is a zero of the polynomial. We could say x equals c is a solution of the equation p of x equals 0. We could say x minus c is a factor of the polynomial, or we could say c is an x-intercept of the graph of the polynomial. So it's important that you understand the relationship between the factors and the zeros, which remember also represent the x-intercepts or the solutions. Okay, so we've been factoring polynomials, and the reason we may want to factor a polynomial is so we could find the zeros. So let's do that. So in order to find the zeros by factoring, we always want to set p of x or f of x. We're just using p of x here for polynomial. But you always want to set the equation equal to 0. Okay, now our polynomial is already in standard form. So the next thing I would do is look for a greatest common factor of all three terms. And just a bit of advice, if your polynomial leads off with a negative, I would factor the negative out as part of your GCF. So as I'm looking at this polynomial, I'm noticing I can factor out an x, a negative x, out of each term. And if I do that, that'll leave me with positive x squared minus x minus 12. Okay, now remember, after you factor out your GCF, you want to count the terms. I'm left with x squared minus x minus 12 in parentheses, which has 3 terms. So because it has 3 terms, I can try to break up the trinomial into factors of 2 binomials. Okay, so this is where we would think factors of negative 12 that add to negative 1. So negative 4, positive 3 would work. So we've got our 3 factors. So like we're right here, okay? We have our factors. So to find the solutions for x, we're going to set each factor equal to 0. And we're going to solve for x. So here I would just divide by negative 1, but 0 divided by negative 1 is still 0. Here I would add 4 to both sides, and we get x equals 4. And then here I would subtract 3. And we get x equals negative 3. And then, of course, we could use our set notation to represent all these zeros. So we were able to go from factors now to solutions where c is also a 0 of the polynomial. Okay. So honestly, this is not new. We've actually been doing this. But there is a little bit more information about the zeros that you can get from the factors. And we call this the multiplicity of the zero. And the multiplicity of the zero tells you the shape of the graph at that x-intercept or near that x-intercept. So it actually works like this. If c is a 0 of the polynomial with a multiplicity m, then the shape of the graph of p near c is as follows. If m is odd, then the graph is going to cross the x-axis at c. So your graph might look like this, or it might look like this. Okay, if m is even, then the graph will only touch the x-axis at c. Okay, so it might look something like this, or maybe like this. So the multiplicity tells you whether the graph crosses at that 0 or touches at that 0. Okay, so you can also remember this in terms of if m is odd, the graph crosses at that 0. If m is even, the graph just touches at that 0. Okay, so let's look at an example. So we're given a polynomial. The first thing we want to do is set it equal to 0, but then we're going to factor. We're just going to try to find the zeros by factoring. Okay, now I'm checking for a GCF, but I'm noticing there's no GCF for all 4 terms. So my next option would be to try and factor by grouping. From the first 2 terms, I can factor out an x squared, which will leave x minus 3. From the last 2 terms, I can factor out a negative 9, which will leave x minus 3. Okay, so remember, from that we get x squared minus 9 from the GCS that we factored out, times x minus 3. And then remember, you always want to, keep checking your factors. Can we factor any further? Well, we can. We have x squared minus 9, which is difference of squares. So I can break that up into x plus 3 times x minus 3, and then we have the original x minus 3. Okay, now since we have x minus 3 times x minus 3, that is saying we're multiplying that factor twice, because it comes up twice in our list of factors. But remember, we could also write that as x minus 3 squared. Okay, so the m that I was talking about up here is the exponent, okay? So this is m, okay? M is the exponent on the factor, or how many times you're multiplying that factor. So, when we set each factor equal to 0, we'll set x plus 3 equal to 0, and then subtract 3 on both sides, and we get x equals negative 3. Technically, what we're saying is that x equals negative 3 with a multiplicity of 1. Okay? So this 0 has a multiplicity of 1. Where the x minus 3 set equal to 0, which gives us x equals 3, has a multiplicity of 2. It means that that factor is squared. It's multiplied twice. Okay. Now, what does that tell us about the graph? That means when x equals negative 3, the graph crosses the x-axis, and when x equals 3, the graph just touches the x-axis. So that's going to be important, especially later when we get to graphing these polynomials. Okay, but we do know, based on this, that the graph touches at x equals negative 3, and we know the graph crosses, or excuse me, we should have those reversed. The graph crosses at negative 3. And the graph touches at positive 3. Too many 3's. Okay. All right, so that's what I mean by the multiplicity. Okay, so here when we were talking about m being odd and m being even, m would be the exponent on the factors. Okay. Now, honestly, you guys, usually when we write the zeros, we don't typically write multiplicity of 1, like it's kind of understood already. But if a 0 has a multiplicity of 2, that would not be typically understood, so you would want to write x equals 3 with a multiplicity of 2. Okay. All right, now, we can also use the zeros in reverse. So let's say that we're given the zeros of the polynomial, and we want to write the equation of the polynomial. We can do that. So let's say we know that these are the zeros of the polynomial, negative 3, 0, and 1. Well, knowing the zeros, we can always write the factors. So we can work this backwards. Okay, so keep in mind, if negative 3 is a 0, that would mean x plus 3 is a factor. If 0 is a 0, I know that sounds weird, then that means x is a factor. And if 1 is a 0, that means x minus 1 is a factor. Okay, so I hope you see where we're just going backwards. We're starting with the zeros and we're writing the factors. And then once we have the factors, we can just multiply it out to get the polynomial in standard form. So what I would do is I'd probably first distribute x, and then we would just have to FOIL. So I would multiply x squared times x to get x cubed, x squared times negative 1 to get negative x squared, 3x times x is 3x squared, and then 3x times negative 1 is negative 3x. And so this is a polynomial of degree 3 that has those zeros. Okay. All right. Now, what if we're given a graph? We can find an equation that represents the graph. So the idea is the same. Graphically, we can look for the x-intercepts, which are the zeros. So my zeros in this case would be negative 1, 1, and 2. And then knowing the zeros, I can write the factors, x plus 1, x minus 1, x minus 2, and then I can just multiply them out to get the equation in standard form. So I think I'm going to start here with the x plus 1 times x minus 1, because that's the difference of squares. So when you FOIL that out, you're going to get x squared minus 1. Okay, bring down the x minus 2, and then we'll FOIL again. X squared times x is x cubed. X squared times negative 2 is negative 2x squared. Negative 1 times x is negative 1x. And then negative 1 times negative 2 is positive 2. So this is a polynomial that could represent that graph. Now the reason I say could is because there are some different possibilities. Okay. All right, let's look at one more example. Again, we're given a graph, okay? Now, I actually want to go back to the previous graph. Notice that this graph crossed at each 0. So that's why I only listed those numbers one time. Because since the graph crosses at each 0, I can tell that that 0 has odd multiplicity, okay? Which is different when we look at this graph. So when we look at this graph, I can tell that the zeros are negative 2 with a multiplicity of 2. Now, how do I know that? I know that because the graph only touches at that 0. Okay? My other 0 is 1, which also has a multiplicity of 2. It has even multiplicity. Okay? Again, I know that because the graph only touches at that 0. Okay? So, that means when I write my factors, I want to write, if negative 2 is the 0, x plus 2 is the factor, but it would be squared. If 1 is the 0, x minus 1 is the factor, but it would also be squared. Okay, so in order to multiply all this out, I want to expand. X plus 2 squared means you're multiplying x plus 2 times itself. X minus 1 squared means you're multiplying x minus 1 times itself. And then we just have to do a whole bunch of multiplying. So I think I'm going to start here and FOIL this out, which would give me x squared plus 4x plus 4. And if I FOIL here, I'll get x squared minus 2x plus 1. And then I'm multiplying a trinomial by another trinomial. So let's just take this step by step. I'm going to multiply the x squared by all three terms in the other polynomial. So x squared times x squared is x to the fourth. X squared times negative 2x is negative 2x cubed. X squared times 1 is x squared. Okay, and then we have to do the same with the 4x. Okay, so 4x times x squared is 4x cubed. 4x times negative 2x is negative 8x squared. And then 4x times 1 is 4x. And now I'm going to do the same thing with 4. So 4 times x squared is 4x squared. 4 times negative 2x is negative 8x. And 4 times 1 is 4. Okay, then we just have to combine like terms. So I don't have another x to the fourth, so I'm just going to bring that down. Okay, then I would look for my x cubed. I have a negative 2x cubed plus 4x cubed. So that would be positive 2x cubed. And I like to cross them out after I combine them, just makes it easier. Okay, let's go down to the x squareds. I have 1x squared minus 8x squared. That's negative 7x squared plus 4x squared would be negative 3x squared. Okay, got those. All right, down to the x's. 4x minus 8x would be negative 4x. And then we have our plus 4. Okay, so this polynomial could represent that graph. All right, so again, you guys, here we're just kind of flipping things around. You're starting with the zeros and then you're writing the factors and then you're just multiplying everything out to find the equation for the polynomial. But one thing a little new in this video would be the multiplicity of the zero. So, all right, you guys, we'll definitely practice this some more in class tomorrow. And as always, thank you for watching and have a good night.